Hi everyone. In this question, we solve the question decode string at index. So what is given in the question? We are given a string. Okay. We have to decode the string. The encoded string is read one by one, one character at a time. Okay. So if the character is a letter, then it is written on the tape. Okay. Tape is basically the encoded version of the string. Okay. And whenever we encounter a digit, that means the entire tape, the entire encoded version. Let's suppose we are taking example of this test case, lead code 3. That means these. So we are traversing this string one character at a time. So when we encounter this, when we encounter a letter, we write it into the tape. So let us suppose we have this string that stores our answer or encoded version of this string. So we have L, then we have E, then we have E, then we have T. And whenever we encounter a digit, that means the entire current tape is repeatedly written d minus 1 more times in total. So that means when we encounter 2, so this tape is written d minus 1, that is one more time. Okay, so this is what we are given. Now what we have to do next in the question, we are given an integer k and we have to return the kth letter in the decoded string. So this is our decoded string we are getting. This is our decoded string. We have to find the kth index in this decoded string. So it seems to be a very simple problem. Let us analyze this test case, lead to code 3. Okay, so we are given this test case, lead to code 3. Now we traverse this string. This is the encoded version of the string. This is the decoded version of the string. We traverse this string one character at a time, and whenever we encounter a letter, we store it into a decoded version. So when we encounter L, we store it here, E, E, T, and whenever we encounter a digit, we write d minus 1. That is the digit which we have encountered 2 minus 1 times. We return the same decoded string. So what we'll get, we get one more time lead. Then we again move here. We found a D, we found a C, then we found a E, O, then we found a D, then we found a E. Then again we found a digit. So this whole decoded version would be repeatedly written 3 minus 1, that is 2 times. So what we'll get, lead code 3 times as a decoded version of the string. So we get lead code, then again we get lead code, and from this decoded version we have to return the kth index. So we are given the one based index. Okay, so we basically have to return k minus 1th index of this decoded string. So in this example, what we are given, 10th. That means k is given as 10. So we basically have to return the 9th index. Okay, so what is the 9th index? 1 0 1 2 3 4 5 6 7 8 and 9. So this is our 9th index, and we'll return O as our output. Okay, this is the simple question. Okay, but there's a twist in it. If we decode this given string and store it into another string, then this string would take more than more space. Okay, this string, the decoded version of the given string, will take so much of space. Okay, so it increases our space complexity such that we get a memory limit exceed error. Okay, so for the bigger test case, this approach will fail. Okay, now if this approach fail, now how do we approach this question? Now if we cannot simply find the decoded version, we have to do something to get it. So Let's analyze this test case. Okay, we are given the encoded string. So in the previous approach, we are finding the decoded string, the whole decoded string first, and then finding the kth index in that string. This approach, the previous approach, will give us the memory limit exceed error. Because I have tried it, so I insist you to first try the previous approach, then move forward for this approach. Okay, now what we'll do, first thing what we'll do, we'll find the length of the decoded string that can be formed using this encoded string. So what would be the length? 4 characters. These characters will remain as it is in our decoded string into 2 because they are repeatedly written in the decoded string. D minus 1 time, that is basically 2 times. Okay, plus 4 into 3, because in this particular string these 4 characters remains as it is, and this whole string will become its 3 times. Okay, so what is the length of the decoded string here? We get 8 plus 4, that is equals to 12, into 3, we get 36. So this 36 is the length of the decoded string. Okay, now we get the length of the decoded string as one second. We get the length of the decoded string as 36. In this case, we get length as 36. Now what we'll do, we will traverse this encoded string from backwards. Why we are doing from backward, I will tell you. Okay, traverse the encoded string from the back side. Okay, and what we'll do, whenever we encounter a digit, we divide the whole size by the number of digit. Let's suppose we encounter, our size is x, we encounter 3, we divide x by 3. Okay, let's suppose we make it general. Okay, we divide it by d if the d is the digit. Okay, and whenever we encounter a character, we decrease the size by 1. Okay, and at every step what we are doing, we are finding k mod x, and whenever our k become equals to 0, that means we have reached our answer. Okay, so this is the particular algorithm that we'll use. Okay, now I'll explain you the intuition behind the algorithm. Okay, now this is the test case, lead to code 3. We have got the length of the decoded string. Now we traverse this string, encoded string, from the backward. So the first character which we encountered is our digit. Now what we have said in the algorithm, if we found a digit, we divide the size. Let's suppose it is x, we divide it by the digit which we have encountered. So we divide this 36 by 3. 36 by 3, we get 12. Okay, now at every step what we are doing, we are finding k mod x. Okay, at every step. So at the starting, what we'll do, at the starting, the first initial step is to find k mod x. So what is k? K is, on the first step, k is 10, mod 36 equals to k. Is k equals to 0? No, it is not. It is equals to 10. Okay, so k is initially 10, and our size now become 12. Okay, now we move to this character. This is a character, that means we have first thing what we'll do, we'll check k mod x. K mod x, that is k mod the size, it is again 10. Okay, it is not equals to 0. Then we check is if this digit, if this character is a digit. This is not a digit, so we'll decrease size by 1. Now our size will become 11. Okay, now we move here, we again compute k. So this time 10 mod 11, we get again 10. 10 equals to 0. No, it is not. We'll check if this particular character is a digit or not. It is not a digit, so we'll decrease our size by 1. Now our size will become 10. Now we again check for this character the value of k. So 10 mod 10 is equals to 0. That means this if condition will be executed, k equals to 0. That means we have found our answer. So here we'll return, what we'll return? The character s of I, this particular character, that is O. Let us analyze this in one more test case. On one more test case we have HA22. Okay, this is the test case. What will be the length of the decoded string? We have these two characters as it is, these two digit into 2 into 2. We have 4 into 2, 8. The length of the decoded string will be 8. And what will be the decoded string? Let us write here. The length is 8. What will be the decoded string? Ha, 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 ha. This will be the decoded string. Okay. And in this decoded string, we have to find k equals to, let's suppose 3. Okay. K is 3. Let me. Okay. K equals to 3. Now, the same thing we'll do, we'll find the length. Then the first step in our algorithm, we found the value of k. K mod L, that is 3 mod 8 is equals to k. Is the value of k equals to 0? No, it is not. K equals to 3. Now, what we encounter by traversing this string from the backward direction, if this particular character is a digit, we'll divide our length by this. So we'll get L8 by 2. We'll get 4. Okay. Now we again at next step we'll compute the value of k. K mod 4. Is it equals to 0? Is it not? It is not. K equals to 3 we are getting. Okay. Now, is this particular character a digit? Yes, it is a digit. We divide our length by 2. We'll get character as 1. Size as 1. Size as 2. Sorry. We'll get size as 2. Okay. Now our next step is to find value of k. K mod 2. K mod 2. We are getting 3 mod 2. We are getting k as 1. Is it equals to 0? No, it is not equals to 0. So we will not find our answer till this point. Now we check this character. Is this a digit? It is not a digit. That means we have to decrease the size by 1. Okay. We'll decrease the size. Size is currently 2. We'll decrease by 1. It will become 1. Now our next step will be, for this character, we'll find the value of k. K equals to k mod size. That particularly means 1 mod 1. We'll get the value as 0. Now we get the value as 0. That means we have found our answer and we'll return the current index which we are at. So we'll return h. Is our answer correct? In the one based indexing, when the k is given as 3, this is the particular character which we want. Is this matches our answer? Yes, it matches our answer. So this is how we solve the question. Now, what is the intuition behind this approach? Now I'll tell you the intuition. Okay. At every step, what we are doing, whenever we found a character, we just move it into a decoded string. Okay. Let's suppose we take this example. This is the sample test case. Whenever we found a character, we just move it into a decoded version. Okay, now its length would be 4. It will be twice whenever we found a digit, whatever will be the digit is. Okay, then again 4 will be added to our decoded length, and then it will become thrice. Now what we are doing, while traversing it backward, at the end we are getting 36. While traversing it backward, whenever we found, at every step what we are checking for the scene where k mod the size becomes 0. That means we have reached a particular index we are searching for. Okay, this is the motive of k. And whenever we found a digit, we divide it, because at that time we are finding the decoded string, we are multiplying now. So whenever we are find a particular character, we are dividing it by 3, because it is particularly clear to us that the character which we are searching will be present in this particular string. Okay, it cannot be found anywhere else apart from this string. Okay, now our x will, whenever we found a digit, we divide our current size by the current digit. Whenever we found a character, we just decrease by 1, because at the time when we found a character, when finding the length of the decoded string, we are adding 1 to its 1 to the length of the decoded string. Okay, whenever we found a character, now while traversing backward we decrease, so here we decrease by 1. Okay, and whenever we found the value of k mod x equals to 0, that means we have found our answer, and we return the current index which we are particularly at by checking if the current index which we are particularly at is a character. It cannot be a digit. Okay, it cannot be a digit. Okay, so when we write the code, first of all, this is the code for this. First of all, let's suppose s is our string. Now we have to find the length. So let's suppose x is the long integer, because the length, it is given in the constraint that the length of the decoded string will be less than 2 to the power 63. So we have to use, because the range of int is from 2 to the power 31 minus 1 to minus 23 minus 2 to the power 23 minus 1. Okay, so we have to use a long integer to find the length of the decoded string. Now what we have to do, we have to traverse this string. Whenever we find a character, let's suppose because we have to traverse all the characters that are in this string, so we can use the for range loop. So for every character, if it is a digit, then what we'll do, we found the particular digit, let's suppose we name it n, found the particular digit, then we multiply our current x with n. Okay, and make it our current value. Else what we'll do, when we found a character, we'll increase our size by 1. This is the particular code to find the length of the decoded string. Now we move to the next part. What we'll do, we'll traverse this string from the backward direction. So we have our loop starting from the last index till we reach the first index. Okay, if the first thing what we are doing, we are given k in the question. Okay, so if k mod the size is x, we are computing it, and if k equals to 0, what we are doing, we are returning the value by checking if k equals to 0 and the particular character which we are at, if it is a alphabet. So we can use is alpha of s of I. Okay, if it is a alphabet, then what we'll do, we'll return this particular character. Okay, now if this condition does not satisfy, that means we haven't got our answer. So what we'll do, we'll find if up if this particular character is a digit or not. So we'll have this digit function in which we pass this particular character and find if it is a digit. Then what we'll do, we'll make our x divide by s of I. That particularly means when we find a digit, we divide our current size by that particular digit. Is it simple? Yes, it is. Then else what we'll do, we'll decrease the size. When we find a particular character is not a digit, we'll decrease it by 1, and we'll definitely return, because there might be the condition whenever our k value will not be found in the string. Okay, then we'll return null character. Okay, we'll return null. Okay, so this is the particular code for the question. Our loop ends here. Okay, our loop ends here. It is the condition after the loop. Okay, now this is the particular whole code I have written of the question. So if you have any doubt, please feel free to ask. So it is an important question that is asked in Amazon. Okay, Amazon. Okay, so if you are preparing for Amazon interview, please stay tuned to this channel. Okay, bye.